So here I am going to deliver the 1 bit memory cell, that is called the flip-flop. So flip-flop is also known as a latch, and this latch is a electronic logic circuit that has two inputs and only one output. Stored data values, non-volatile, will not lose value over time, often incorporated in static memory. So there are number of types of flip-flops. So but there are okay, the flip-flops first type starts from SR flip-flop, set reset flip-flop or set reset latch, D flip-flop or data flip-flop, T flip-flop or toggle flip-flop, and JK flip-flop. So memory can store 1 bit data, that means one flip-flop store 1 bit data, so either 0 or either 1. So flip-flop are basically technology behind a computer memory chip. So let's start the SR flip-flop. So SR flip-flop stands for set reset flip-flop. Set means 1 and reset means 0. So flip-flop has 1 bit, then we call it set mode of flip-flop. So flip-flop has 0 bit, we call it the reset mode of flip-flop. This is simple flip-flop is basically 1 bit memory bistable device. So that has two inputs, one which will be set the device, that means meaning is output is 1 and is labeled S, and one which will reset the device, meaning the output 0, label R. So SR flip-flop, so inputs you apply as S is equal to 0, R is equal to 0, then S is equal to 1, R is equal to 0, that means set the flip-flop. R is equal to 0, that means reset mode, but R is equal to 1 and S is equal to 0, we call it reset mode. So 0 0 input, so so the mode is 0, that is clear mode, but 1 0 input, they said output is 1, then 1 0 input, the output is 0, and the condition of both the inputs are 1 1, then this is called as a race condition. That means we don't predict, or the internal diagram not give you the n type of output. So this is internal diagram of SR flip-flops. There are total 4 NAND gates. So the last two NAND gate connected cross coupled, that means output to input, output to input. There are two output condition, Q and Q bar. So that means output of any memory always complementary to each other. So S and R, there are two input, and then the output changes as per the clock applies. C stands for clock. This is nothing but the square type waveform. So it has two trigger level, high and low. So here this is just I will show you the condition. This is high trigger level and this is low trigger level. This is set and this is reset input, and there are two outputs, Q and Q bar. So the input 0 0, the output is previous as it is, that means 0 and 1. Suppose output is 1, so Qn is nothing but the previous output, and Qn plus 1 will be next output. So 0 1, then the clear mode because of set 0 and reset 1. Suppose this is 0 and this is 0, the first condition both the output as it is, that means Qn. 0 1 output is equal to 1 0. So next condition, so here the output first no change, then clear change, then set, and then last one it will be, so input 1 1, the condition will be race conditions. So D flip-flop, the next data flip-flop. So data flip-flop, how to explain the data flip-flop? So first of all, you try to understand the data flip, how to make the D flip-flop. So you take the SR flip-flop as it is, the SR, but now you take the one NOT gate and which is connected externally, and now then the NOT gate is connected in between, not get connected between the source and set and reset input. So this is only one input, so input is D, and there are two output Q and Q bar, and now your connection externally. So SR flip-flop as it is, this is SR flip-flop, and now externally you connect the NOT gate from S terminal to R terminal. So only one input, that means the D is equal to 0, the condition is 0, that means clear condition, output is 0, that means same input and same output, 0 input 0 output, 1 input, that is set mode, that means the one output. So here 0, so 0 coming to here, 0 coming to here, and 1 coming to here, then the 0 coming to the NAND gate, so output is 1. So one output coming to the NAND gate, and suppose if we consider the second one to suppose 1 is here and 1 is here, the 1 1 0, so output is 1, and 1 1, then output is equal to 0. So NAND gate table you just recall, then 0, the condition satisfies, 0 0 input output 1, 1 1 input output 0, that means, so you focus here, the 0 input 0 output, so 0 input 0 output, so this is called as a NAND gate. Second condition, so suppose your input is 1, so 1 coming to here, 1 coming to 0 coming to here, because NOT gate, 1 is here, 0 is here, this is also 1 1 1 output of NAND gate 0, first NAND gate, so 1 0 output is 1, so 0 coming to this NAND gate, by default output is 1, so 1 is coming into here, 1 1 output 0, 0 coming to here, the output is 0. So here you mention that, so 1 input 1 output, that means set mode of D flip-flop. So D flip-flop, some important points are, it acts a simple memory or latch. So D flip-flop most of the time use in a shift register, that means all the register use in a microcontroller or microprocessor, that means the accumulator, A register, B register, all RAM memory and ROM memory, so contains the D flip-flop. So Qn, you always keep in mind, Qn is a previous state of the memory, and Qn plus 1 is a next state of memory. So most widely used flip-flop, simple to build and design the D flip-flop. So register comprise several D flip-flops, one of the bit to be stored, but one D flip-flop store the one bit, that means number of bits is equal to number of flip-flops. For example, 4-bit flip-flops required 4 flip-flops, 8-bit flip-flop required 8 flip-flops. Second important flip-flop type is JK flip-flop. So JK flip-flop is termed from Jack Kilby from Texas Instrument, so that's why the JK, one of the most useful and versatile flip-flops. So some of the important points here. So you know that the drawback of SR flip-flop, suppose when the inputs are 1 1, at that time race around condition form, that means the last two NAND gate going to the race mode, because of both NAND gate trying to give the output is equal to 1, that's why the output not predict. So the remaining part, as it is only one important is to be, so we take the feedback from output to the input side, that means, but in cross coupled, the Q bar connected to the S input and Q connected to the R input. So the remaining part as it is, but you apply the 1 1 input, at that time you will get the Qn bar output. So you focus only on the table. So most of the time the tables always confuse you, but now don't take a tension. So here we take a simple example. So which how to use the table. So you are concentrating on the two condition only. So here the table, so your table is just accessing this point. So input 0 0, no change. You know that there are two types of output. One is your previous output and second is your next output, and the states are given to here. So what are the condition of the flip-flop? So 0 0 input, J0 K0, then no change condition, that means previous output as it is. 0 1, that means clear state. Then the 1 0, that means steady state, and 1 1, that means given state. So you just keep in mind, this is the condition of flip-flop: reset, set and toggle, and then no change. You are focusing on that points. So toggle flip-flop, so we just convert this JK flip-flop into T flip-flop. So you just sorted the how to convert the JK into T flip-flop. You just sort these two terminals. You just observe the J and K terminal shorted together externally, and now then the inputs become 1 T and outputs are 2. So toggling means it just you apply the 1, at that time output will be 0, and you apply the 0, what will be the output? 1, because of toggling. Toggle switch is just a toggle switch. So 0 QN bar output and 1 QN output. You just focus on the only two conditions. So this condition shows by, so this is only, this is two columns. So 0 input QN bar and one input, sorry, one input, then QN, that is toggling. So here the flip-flop symbol and applications. So flip-flop symbol is just rectangle, and inside that there are the input terminals name and output terminal, and the middle is external clock signal. So Q and Q bar always two outputs, and J and K, then SR, R, T and D single input output. Block diagram of microprocessor. So this microprocessor and microcontroller I will cover in a next slide. Thank you for listening me.